Okay, so I don't feel like I did evolution justice yesterday, so today I'm going to talk about it a bit more. I was in a bit of a rush, and I'm going to have to decide, I think, with these videos of whether I just keep them all as I record them. So far I haven't done any editing or any sort of overarching structure. I'm just talking about what I feel like on the morning. But evolution is such an important concept that I think, again, it's such a foundational part of my worldview and my predictive modelling, that I feel like it is worth spending a bit more time on it, just to make sure that that we're all on the same page about what we understand it to be, and so we kind of in our bones feel how it is, like the police with the homicide victim. We really do have a clear physical chain of events that's led to humans and to modern humans. The beginning of life is somewhat murky, and that's an area that I'd like to explore at some point. I have my own theories about it, like many things, about the origins of life, but life is such a powerful force in the world, and I suspect probably in the universe. I have no doubt at all that we will be finding versions of life on other planets, and I suspect it will all look pretty similar, because I think there's some foundational rules of life, just like there's rules of physics, so force equals mass times acceleration, E equals half mv squared. Those equations have been worked out by observation, by measurements, by experiments, by carefully examining the physical world, and I think we can discover a lot of stuff about life the same way. So I think there are rules of life, just like there are rules of physics, or rules of biology or laws of biology, whatever you want to call it. There are some foundational underlying relationships that can be described mathematically that make life inevitable. And when I say life, again, it's difficult to actually get a definition of life that covers all of the different forms that we've observed on this planet. But there seem to be some critical key elements. So one is replication. The ability to make a copy of yourself seems to be critical. And I suspect that's because evolution needs something to work on. That sounds backward, but I'll try and explain that essentially every copy of an organism is an opportunity for the organism to experiment with slight variation, slight differences that could give it an edge in the environment that it's in, and particularly if the environment changes. So I think one of the key aspects of life is that it's adaptable, that organisms have the capacity to exploit niches in the environment. So I'm getting a bit off track here, so let me get back to the rules of life. So one is replication, and if you replicate, then you have to die. So I think also living things have to be able to die, otherwise they're not really alive. So that's one, and probably the key one. So maybe we'll spend a bit more time on that, of why replication is such an important feature of life. And just simply, if you do a thought experiment, if, say, in the beginning of the world, where we think there's probably this sort of primordial soup of a liquid world with sort of fairly complex chemical molecules floating around it, and we know that such molecules can form spontaneously just through the properties of atoms. If some molecules persist for longer than others, in the state that they form a stable structure, then they will survive. So a bit like rocks, crystals are a stable structure, so those things will have greater longevity than structures that are unstable. But things that could make a copy of themselves, so if you've had some molecule that could induce other molecules similar to itself to form, so it catalysed a reaction where it formed something similar to itself, then those molecules will also come to dominate. And they may not need to have a very long life at all, they just need to be able to rapidly make copies of themselves. And so even if they died quite shortly after they made the next copy, as long as they made two in the time that they lived, eventually they will take over the whole soup. So replication is almost built in right from the beginning as a fundamental component of life. And then replication with variation is the key. So making a copy of yourself, but not making an exact copy every time. And the ratio of stability to flexibility is also a critical component of structures and substances that evolution can work on. So you need to replicate with enough fidelity that you're recognisably the same as your parent molecule, but with sufficient flexibility that the variations make some of your offspring, some of your descendants, more likely to survive than others, or to be able to survive in different environmental conditions, so that you don't put all your eggs in one basket. Anyway, those are just my thoughts for this morning, and I've doubled my time again. It is the weekend, so maybe I'll cut myself some slack. Anyway, I'll see you tomorrow. Thanks.